Hello all, ADC, which stands for analog to digital converter, is one of the commonly used chips in embedded applications, right? So we have several specifications and types of ADCs to choose, and there are a wide um, range of portfolios available from different manufacturers for the ADC chips. Now, one of the specification or one of the requirement for ADC is basically the sampling time, right? So the sampling time is a very critical factor which determines the speed of the ADC, right? Now that is predominantly, the sampling period is predominantly dependent on the clock that we supply to the ADC. So this clock to the ADCs can be supplied in two ways. One is ADCs that have internal oscillators, basically do not need any external clock to be provided. So this is where internal oscillator accuracy plays a crucial role in the performance of the ADC. So basically these are more of low level applications where you don't too much of accuracy. That's where we generally use these ADCs with internal clock oscillators. Now external clocks. So if you are giving an external clock, means um, definitely you can understand that it is a very critical application. So this external clock can be two scenarios. One is external clock by directly giving the clock from a crystal that is connected to this ADC chip. That is one scenario. And second one, generally we use ADCs in a system, and we might have multiple ADCs as well sometimes, which need to be in sync to get the output and combine those outputs towards the host side. So in those scenarios, we need clock from the controller of the processor which we are using to read the data. So again, this is one more scenario. So all these clock scenarios are present in ADC, and when you are designing application, selecting an ADC during the architecture level, you should have an idea of what are you going to consider as a part of this ADC clock requirement. Let us consider ADS1115 ADC, which is a commonly available and used by many engineers outside as an example to explain the clocking scenarios in the ADC. So here, this ADC has a sampling rate of 860 samples per second. So straight away, okay, you basically need some clock, definitely more than that, to achieve the required sampling rate, right? So this ADS, if you go to the clocking requirements of this, okay, so if you see here, ADS1115 have an internal oscillator which is basically running at 1 megahertz. This is the internal clock frequency. Now, the important point to remember here is, if you are using ADS1115, you cannot connect external clock to ADC and sync with other devices. So that is ruled out. As we discussed, the major problem with having the internal oscillator is it drifts over temperature and time. The consequence of this is the output data rate scales proportionally with oscillator frequency. That's the important factor, as we talked before. The tolerance, frequency tolerance, or basically we should say the variance of this particular oscillator, internal oscillator, is a cause of concern for the engineers, where you don't have any control. You have to follow the specs provided by the ADC, and definitely there'll be a variance with that, and which actually varies the rate at which output is being generated from this ADC.